All right, guys. Today we are looking at lesson 70, solving inequalities by multiplying or dividing. We had a lesson similar to this a few lessons ago when we worked on solving inequalities through addition and subtraction. And it was quite similar to solving inequalities or solving equations using addition and subtraction. And we're going to find a lot of similarities and one sneaky little difference here today when we're talking about solving inequalities by multiplying or dividing. Okay? So let's start here with this equation, 1/3 x. I'm going to rewrite it because it's easier for me to see if I write it this way than if it's in this kind of format. So 1/3 x is greater than or equal to 2. I want to isolate x so that I can graph this inequality on a number line. So in order to get rid of 1/3, I need to multiply it by its reciprocal, which is 3/1. And I just need to make sure I do that over here on the same side, on the other side. Whatever I do to one side, I want to do to the other. And I end up with x is greater than or equal to 6. I can go ahead and plot that on a number line. Okay, and I'm going to go ahead, let's see, if I want x to be greater than 6, I think I'll put my 0 right about here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that'll be 10. 1, 2, 3, 4. This is 5, 6, 7, 8, 9, 10, and so on. Okay? Okay, now I'm going to go ahead and use a colored pencil. If you want to use a color, feel free. If not, your regular pencil will work just fine. And I'm going to plot a point here at 6. And I'm going to make sure that I fill it in because I want my solution set to include, it's got an or equal to, right? I want it to include 6 and all of the values greater than 6. Okay, now I want to go ahead and check my work. So I'm going to put my end point, which is 6, back into the original equation. Okay, so I've got 1/3 times 6 needs to be greater than or equal to 2. 6/3 is the same as 2. Is 2 greater than or equal to 2? The answer is yes. And I could check any value greater than 6 to put it back into this equation and make sure that I have done my calculations correctly, and it looks like I have. So I'm going to go on here to the next problem, but again, as you test on this, as you work through this in your homework, feel free to put in multiple points and check your work. This looks like quite a similar equation where I've got 1/3 n is less than 2. If I want to get n by itself so that I can plot this on a number line, then I'm going to multiply 1/3 by its reciprocal, which is 3/1. Multiply this side by 3/1, right? This goes away, becomes 1, and we have n is less than 6. So I'm going to put that now on a number line. And I think I will put my 0 right about here. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make that 8. 1, 2, 3, 4, 5, 6, 7, 8. And here are a few negative numbers. I'm going to go ahead and take my color. Now this time, because it doesn't have an or equal to sign, I'm going to use an open circle, meaning that I'm going to plot this point at 6, but I'm not going to include it in the solution set. So 6 is not included, but every single value that's less than 6 is. So let's check that work, okay? So I'm going to pick one of these values that's less than 6. I don't know, I'll go ahead and try 3. I'm going to put back into this original equation here. So 1/3 times 3/1 is less than 2. Let's check that to see if it's true. So 1/3 times 3/1 is 1. 1 is less than 2. Check. Okay, so I got it. Now, here's where the sneaky little difference comes in. When we have an inequality that has a negative sign here, where our variable is, If we want to isolate that variable so that it's positive, we recognize that we're going to need to multiply by a negative number, right? In order to make that x positive. If I were to rewrite this equation, I could see it as negative 1/2 x is less than 7. That's what I've got here. Okay? If I want to get this x by itself, I got to get rid of this negative 1/2. And in order to do that, I need to multiply it so that x is positive. I need to multiply it by negative 2 over 1. The reciprocal also needs to be negative in order for me to have a positive x. Now when I multiply the other side by the negative 2 over 1, here's the sneaky little thing that happens. Okay, these cross out, this becomes just 1, and here's my x. But whenever I multiply or divide, for that matter, by a negative number, when I multiply or divide an inequality by a negative number, the direction of the inequality changes. So where it was less than, it's going to become greater than, and I've got 7 times negative 2, which is negative 14. We don't do this, obviously, when we have an equal sign. Okay, we can multiply by negative numbers. It doesn't change the equal sign. However, when we multiply or divide an inequality by a negative number, the direction of the inequality changes. It flips. Okay, so now I'm going to go ahead and plot this on a number line, and I have x being greater than, not equal to, so I'm just going to be an open circle, all values, x is going to equal all values greater than negative 14. So if I put negative 14 right here, I have to think carefully, right? If this is negative 15, negative 16, these values are actually less than this. So greater than means that I'm going to be climbing back up that negative scale. Negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, negative 7, and so on. Now when I go to plot the point at negative 14, it's going to be an open circle because it doesn't have an equal sign there, so I don't want to include it in the solution set. And x is all values that are greater than, that means it's going this direction, it's getting closer and closer to 0, because those numbers are bigger. Now when I go ahead and go back in and test, I don't want to include this point. I could, but I would, I would get it negative 14 equals negative 14, which is true, but this inequality isn't going to work for that, which is exactly what I want. I don't want negative 14 to work out as a solution because I didn't include it, but any of these values should work in this original inequality. Let's see if they do. Let's just pick negative 10. Okay, so here I've got negative 10 over 2 is less than 7. Is that true? Okay, so essentially this becomes, my two negatives here make this a positive, right? And I'm going to end up with 10 divided by 2, which is 5, is less than 7. And yes, that checks out. Okay, let's see if we can do the next one, remembering that sneaky little trick that when I multiply or divide by a negative number, the direction of the inequality flips. Okay? All right, so I'm going to rewrite this as negative 1/4 x. It's just easier for me to see. Is less than 8. To get x by itself, I need to multiply by a negative number. In this case, and the negative reciprocal is negative 4 over 1. I will also multiply this side by negative 4 over 1. These will become positive 1. This becomes x. Flip the inequality, because I'm multiplying by a negative number, is now going to be greater than negative 32. A number line is going to look similar. It's just going to have different values on it here, right? So let's put, I don't know, let's make this negative 32. And the numbers that are greater than negative 32, remember climbing back up toward 0, negative 31, negative 30, negative 29, negative 28, negative 27, negative 33 this direction, negative 34, negative 35. Okay. When I go to graph this now, I want an open circle at negative 32. And I want to reflect that x are all values that are greater than but not including negative 32. So this is a direction for the values that are greater than negative 32. Let's go ahead and test one of them. I'm going to pick negative, I guess I can pick negative, you know what, I want to pick negative 28 because I can see that that's going to be a nice clean division right there, okay? So I'm going to pick negative 28. So I've got negative 28 over 4 is less than 8. Is that true? 28 divided by 4 is 7. 7 is less than 8. That is true. Okay. So my answers here, I guess I should go back in and box in my answers. And then I have my graphs, okay, showing how that works out. Now, this same property that applied to multiplication is also true for division. We're going to solve graph and check the solution for 21 is greater than 7x. In this case, we will perform the inverse operation to multiplication, which is division. I'll divide both sides by 7, and I'll end up with 3 is greater than x, and that's what I'm going to graph. The inequality stays the same direction because I divided by a positive number. That sneaky little flip only happens with multiplication or division by negative numbers, okay? So here I will put 0 right here. And 1, 2, 3, 4, 5, that'll do. Let's go the same other direction. And I'll go ahead and graph that. So I've got 3 is greater than x, so all values, I'm going to put a point at 3, open circle. I don't want to include it in the solution set. And x is all values that are less than, see x is on the less than side, okay, less than 3. So it's going to be all of the values that go this way, all of the ones that are less than 3. Okay, and I can go back in and check that in my original equation by substituting any of these numbers in for x. Let's choose 0. That sounds fun. Okay, so 21 is greater than 7 times 0. Is 21 greater than 0? Yes. Fantastic. All right, let's go ahead and solve and then graph and check the solution for the inequality 6w is less than or equal to 57. All right, so in order to do this, I'm going to divide each side, get w by itself, by 6. It's a positive 6, so inequality stays the same direction, and I end up with w is less than, or equal to, 57 divided by 6 I just did on my calculator, and the answer, the quotient is 9.5. Okay, so I've got w is less than or equal to 9.5. When I go ahead and put that on a number line, I'm going to start with 10 right here, 11, 12, and get less as we go. Okay, 9, 8, 7. Okay, now when I go to graph this, I want w, the values for w, to be less than or equal to 9.5. So I'm going to plot a point right here at 9.5. Fill it in because it needs to include 9.5 in the solution set, okay? And all of the values for w are any values that are 9.5 or less. So there's my arrow to indicate that it includes all values that are equal to or less than 9.5. I can go back in, I can put one of these values in. In fact, let's check the endpoint because we included it. Okay, so 6 times 9.5, I'm going to put that back in for w, should be less than or equal to 57. When I multiply 6 by 9.5, I get 57 is less than or equal to 57, which checks out. Fantastic. All right, what do you think we're doing next? I bet you guessed it. We just divided by positive numbers. Now we're going to go ahead and divide by negative numbers. When we divide here by the negative number, we're going to have that same flip in the direction of the inequality. That the direction of the inequality is going to flip when we have to divide by a negative number. So let's work that out. And that's in order to get that positive x, right? So I'm going to divide this by -5, and I'll divide this side by -5. And when I go to get my answer, I'm going to have x, my positive x right here, flip the inequality is greater than or equal to 30 divided by -5 is -6. Okay? Go ahead and put that on a number line. And I think I'll go ahead and go, put my 0 here. 1, 2, 3. 1, 2, 3, 4, 5, 6. -1, -2, 3, 4, 5, 6, and so forth. Okay? All right. The x values need to be greater than or equal to -6, so I'm going to go ahead and fill in the dot here to say -6 is included in the solution set, and x also includes all values that are greater than or equal to that -6 in order to check my work. I want to put in a 1. Let's put in a 1 here. Okay, so I've got -5 times 1. Remember, I need to look back at what this originally was here. That's how I need to check it out, and I get -5 is less than or equal to 30, and that checks out. One more to go, gang. You're doing good work. Hang in there. We've got 1/2 is greater than or equal to -4a. Okay, 1/2 is greater than or equal to -4a. So I want to divide both sides of this equation by -4. I know it's a little bit weird. You can do it on your calculator, or you can do it old school, like we always have, where you multiply, when you divide a fraction, you multiply by its reciprocal, right? So either way, let me just show you both ways. Let me do it the easy way first, and I'll just do it on my calculator. I'm going to put in 0.5 divided by -4. And I get my calculator is showing me, here, I'll show it to you, okay? So you can see, because this is a good trick to remember. So, if I've got, was it -1/2? No, just 1/2. 1/2 divided by -4, I end up with -0.125. And that's fine, but I can convert that to a fraction if I click the math key, and then it says fraction, and I say, yes, please, that's what I would like, number 1. It says, you want the answer to go to a fraction? I hit enter again, yep, and I get -1/8. Okay, so either way you want to do that, if you want to use a calculator, this is the way to do that. And I end up here with -1/8. Don't forget to flip is less than or equal to, this goes away, a. Okay, if I want to do it the old school way, or I don't have a calculator with me, that's okay too. If I'm going to take 1/2 and divide it by -4, that's going to be the same as multiplying it by -1/4. Remember how to do that, guys? Okay, and so then I multiply the numerators and the denominators, and I get -1/8. So either way is perfectly fine. You should get the same answer either way. When I plot this solution on a number line, I can, if I want to be cheeky about it, okay, I can go ahead and put tenths in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this becomes 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's 2. Do it the same other direction. 4, 5, 6, 7, 8, 9. Here's -1. 2, 3, 4, 5, 6, 7, 8, 9. There's -2. Okay, and I've got my little tenths as tick marks in between. So now I can plot exactly where -1/8 is, which is right there, right? Oh, goodness sake. Why did you guys let me put tenths in here? I know you didn't. Can we just pretend like there's only 8 in here? Here. Gosh, guys. I've been doing too many videos today. Here, let's randomly remove 2. Here we go. It's okay if you laugh at me. I should have divided that into 8 equal pieces. Okay, let's pretend like that's 8 equal pieces. Now I can put my dot right here on one of them. And I can see here that A is supposed to be greater than or equal to all values that are more than -1/8. So my arrow is going to go this way. Okay, I can go in now and check my work. I'm going to put 1 in because I like that number. And I want to make sure I put it back into the original equation. So I've got 1/2 is greater than or equal to -4 times 1, which will simplify down to 1/2 is greater than or equal to -4, and that checks out. Our final problem here, application problem, is a real estate agent receives a commission of 3% for every house sold. What price must a home be sold in order for the agent to earn at least $6,000? This should be dollar units right there. So in order to write an equation for this application problem, we recognize that it's going to be the price of the house times 3%, 0.03. The price of the house times 0.03, we want to be greater than or equal to $6,000. Okay, because that agent wants to earn at least $6,000. So that means that 3% of the total price of the house has got to be greater than or equal to $6,000. So how much does the price of the house have to be in order for that to be true? Well, let's divide by 0.03, and it's a positive number, not negative, so this stays same direction. I'm going to divide this by 0.03, and I've got 6,000 divided by, 6,000 divided by 0.03 is a whopping, the price of the house needs to be greater than or equal to $200,000, which is quite reasonable for a house. All right, and so on a $200,000 house, the agent would make $6,000 in commission because that 3% of 200,000 is 6,000. So as long as it's $200,000, the price of the house is $200,000 or more, the agent will make at least $6,000 in commission. Now it doesn't tell me I need to graph it, so I'm not gonna. I'm just gonna put a box around my answer here. And you can move on now to these practice problems, which are 10B and number 12 with a graphing calculator. Okay, 10B and number 12 with a graphing calculator. Now, these problems, guys, as I'm looking at them in my book right here, are using your graphing calculator to graph a box and whisker plot. Okay, so this is a box and whisker plot. And number 12 is using your graphing calculator to graph 2 lines and find their solution set, which is just, they're probably going to intersect. Those lines will intersect and you find the place where they intersect with your graphing calculator. So we haven't done this for a little while, so you might need to go back in your notes to figure out where these are. Where is the lab that we did where we use our graphing calculators to make box and whisker plots, and where is the lab that we did to remember how to graph 2 lines, okay, and then find that intersection point. I think you're looking for outliers here. Yeah, you are graphing the box and whisker plot, and then you are telling your calculator to look for outliers. All right, I think it would be best if you do this on a piece of paper, turn it in to me. It's going to be much too difficult to do on, well, gosh, if you're doing it with a graphing calculator, tell you what, whatever Mrs. Bryden tells you to do, that's what you do, okay? So if we want to work on, how about we'll give you the option. If she wants to split you up or have you guys do this graphing calculator work, that is fantastic. If not, we have some practice problems here on page 459 of your book that would be perfectly fine for you to work through on your whiteboards as well. So maybe she'll let you vote, or maybe she'll just tell you what to do. Either way, we'll get to work on some practice problems, and I am looking forward to seeing you soon, and I will go over in class with you any problems that you have here from your homework from lesson 70.